Okay, before I get into the full tutorial part, so how you go about things as far as completing the homework problems for the first assignment, that's all MATLAB problems anyway, is since what you're doing is you carrying out MATLAB statements or possibly writing MATLAB scripts. What I would suggest is submitting a MATLAB diary. So, so as an example, how this could go. So let's suppose you start a diary file. What? Okay.
Oh, and imagine if you spelled it like dairy.
Oh. I'm sure I've done that now and then. Okay, so I'm just making up a file, homework1.txt. So now that I started the diary file, and then let's suppose I start going through some of the problems, and it'd be a good idea.
Permission denied again.
What?
I got a permission denied again.
Oh, because you're in that folder again. So go over here and okay. Now it should let you do it. Yeah. Okay. So what I would suggest, since there's a lot of problems in this assignment, and any MATLAB diary, before you do anything related to a particular exploration, you put a comment in the diary. So for example, here would be like the first problem is exploration 1.2.1. Just so, because I'm going to be looking through this, and so I can follow what you're doing. Okay. So then you can start going through that. Okay, I'm actually giving away the first part of it, but anyway. And then whatever work you need to do for that. And then at some point you're finished with all that, and then you go on to the next one. Now let's suppose you want to stop for now. So then you can do diary off. So then everything you typed in at the command prompt up to this point is saved in that diary file, that homework1.txt, and I can go ahead and edit that at any time. So that's what I did so far, showing in the editor. And then, so then if I were to close down MATLAB, and then, actually I'm going to close the editor. So if I were to shut down MATLAB completely, then come back later and resume, if I do the diary command with the same file name, so homework1.txt again, and I'm going to go with the next one, like exploration 1, 2, 3. Okay, and so on, and okay, and then diary off. So now, if I open the diary file again, okay, then everything is there. From everything, all of this from the first MATLAB session, and then these last few lines from the second one. And I would suggest.
Is there a way to get rid of the lines?
Well, okay, this is an ordinary text file. Now if I open it in the editor, I can edit this however I like. And actually, I would suggest you do that. Because once you did some things in MATLAB that didn't go right, maybe you typed something wrong, and you don't want to submit that necessarily. So, so you can go through this diary file and clean it up before you submit it. And I recommend you at least take a look at it before you do. So at least that way, so for this first homework, what I would want you to submit to me is, a diary of everything you did for the various explorations, or if you type the commands into M files instead, you could submit that. So diaries and M files. There's one of the explorations toward the end involves producing a plot. I'm going to cover graphics on Tuesday, the last day of the tutorial. So that's the only other thing is that one of the problems calls for producing a plot, and you can save that as like whatever image format, like a JPEG, and you can upload that. So because you can upload whatever kind of files you like to Canvas for any of the assignments. The JPEG or PDF or whatever, these text files.
Can you go back to the command window? Sorry. Why are we laughing?
I think some of your fellow students were startled. Okay. All right, we're here. You have a question about what's in the command window, or?
No, I'm just making sure I understand I was making sure I knew how to turn the diary off.
Okay. And if you're finished with MATLAB anyway, you don't have to do the diary off command. Shutting down MATLAB will obviously turn off the diary. Okay. All right, so any questions about this whole process? Now, okay, now I actually want to switch diaries because I'm about to resume the tutorial. Diary tutorial. Oh, 8:31. Okay. Oh, actually, before I get into that, I'm going to flip over to Canvas. Okay, here in Canvas, on the main page, if you want to download the M files that I will be using today, I should have mentioned this earlier. They're all right here. So go ahead and if you want to do that, take a little time now to download those. And these were ones from last time. Okay. How many of you are using MATLAB online? Anyone?
I am.
Okay. It looks like this.
I am as well.
Okay, so that's a couple of you at least. Okay. So I've used MATLAB online before. Actually, I've had students in the past use it. So I took a little time. Yeah, so the way we work with files is very different because they have this one MATLAB drive. And so for anyone else, okay, so I just Google how to get to it, and it makes you sign into your USM/MathWorks account first. In this case, I'd already done that, and then opening MATLAB online. And when I opened it for the first time, I was surprised. Come on. I was surprised to find these files already there. And I think that's because I've been using the MATLAB app on my iPhone. And I had saved those files there, so I guess there's a connectivity between using MATLAB on your phone and using MATLAB online here.
You can do MATLAB on your phone?
It's very, very, very cumbersome, but yes, you can. So, okay, and so if I contrast, and you can see there's obvious similarity between the MATLAB online user interface and just regular MATLAB here. So in regular MATLAB, I have different folders I can choose from to work with files, like the one I have for this tutorial. And then the default one is, for a Mac, your home directory, documents, MATLAB, and then on Windows, I presume would be my documents, MATLAB. But in MATLAB Online, you don't have that. You just work with the MATLAB drive, and that's it. And I looked at this thinking, well, how, if I have M files on my computer and I want to get them here, how do I do that? And I had to Google to find out that if I do this right or secondary click, I can upload files from my computer into this MATLAB drive, and then I can work with whatever M files are in here. Okay, I just realized that I had better not open these files because they are, okay, I'll simply say that I'm not allowed to. Okay, but, so hopefully, whatever differences there are between MATLAB Online and MATLAB on a laptop or desktop, if there's any difficulties, now I'm taking a look at MATLAB Online myself too, so I can try to help diagnose that. Okay, now, okay. So, continuing with MATLAB programming constructs. Last time we saw if statements, for loops. So next we'll see is a combination of the two. A while loop. So I'm going to edit this file, M file. Now, when I'm using the edit command, here I'm typing in the name of file, guest number.m. I don't actually have to include the .m. If you don't include it, it assumes it. Okay, so actually, before I talk you through this file, I'm going to go ahead and run it. And that'll make it easier to explain. So, like before, it's a script M file. To run a script, you just type the name at the prompt without the .m. Okay. So, MATLAB is taking a number between 1 and 10, and it's wanting me to guess what that number is. So, I'll just go ahead and pick something. Okay, it tells me I got it wrong. Right, let's try something else.
I have a question.
Yes.
When we did this in class the other day, it was working, but now it says I did it and it says it does not exist, but I downloaded it.
Okay, so you downloaded this M file, but it's not finding it?
Yeah.
Okay, okay, so if you look up here, what directory you're in needs to match the directory that you downloaded it to.
Oh, okay.
Yeah, when there's problems accessing files, that's almost always the reason.
Okay. I'll see if I can figure it out.
Okay. Yeah, I could probably put it in its default downloads location, which is not where MATLAB will be looking for it. Actually, that's why I think I have my downloads folder. Oh, nope, not now. I used to, because often I do the student sending me an M file and it downloads with my downloads folder, and that's where I open it. Is that what it is, Morgan?
One second, I'm seeing. I just moved it into the right folder.
Okay.
Yeah, now it's working.
All right, great. Okay, so I keep guessing. At some point, I finally guess the right number, and it tells me that I guess right. So let's look at the code that made that happen. So this first line is generating a random number. Now, rand generates numbers that are between 0 and 1. So if I multiply by 10, that's going to be a double precision floating point number between 0 and 10, but strictly greater than 0, strictly less than 10. Now I want an integer between ranging from 1 to 10. So for that, I use the ceil function, C-E-I-L. Ceil is short for ceiling. So there's more than two. There's certain functions for rounding a floating point number to an integer in MATLAB. So the ceil function rounds up. It takes the real number to the ceiling, the next integer up. There's a floor function that rounds down. There's also just plain old round that rounds to the nearest. Those are different ways of rounding numbers. We'll talk more about rounding and such in the next chapter when we get to floating point arithmetic. But the idea is, because the number, the argument to ceil is between greater than 0 less than 10, by rounding that up, I'm guaranteed to have an integer somewhere in a range from 1 to 10. Okay. Now, then it displays this message. I'm thinking of a number between 1 and 10. And then just like in one of the scripts last time, enter month year, I have it use the input function with this prompt to get my guess. So this line 4 right here, is for getting the first guess. And here we have a while loop. So the way a while loop works, similar to while loops in other programming languages, is you have some condition that would be true or false. As long as the condition is true, then the while loop will keep executing the body of the loop, so the statements between the while and the end. So if I happen to guess right the first time, then guess would be equal to number. This condition would be false, and the loop will never run. It'll go down here and print the message that I guessed right. But if I guess it wrong, this condition, number not equal to guess, would be true. So now it'll go inside the loop, and all the loop does is telling me I got it wrong and telling me to try again. And now I get a new guess. So this value of guess from the second prompting is overriding the old value. So now, after prompting me and it gets my second guess, it goes back up to the top of the while statement, and it's going to evaluate this condition again with the new value and see if that agrees. So as long as I keep getting it wrong, this loop is going to continue to run, continually prompting me for a new guess. Eventually, I'll run out of choices, because unless I'm being silly about it and guessing things over again. At some point, I'll exhaust the supply of numbers 1 through 10, and then this condition will be false, number will be equal to guess, and then control passes down here. So that's the basic idea behind a while loop. A while loop begins with a condition. That condition, as long as it's true, the body of the loop will execute. You should make sure that at some point the condition will become false. Otherwise, the loop would run forever. So you'd have an infinite loop. So any questions about what this code that I've highlighted is doing? So think about a while statement. It's possible that the while loop will not run at all. Like if the condition is false the first time it's encountered. Now, when I ran this before, I was giving proper guesses in numbers between 1 and 10. What if I don't give proper input though? So if I run this again, it's wanting the number between 1 and 10. So I'm gonna be nice and uncooperative and type a word. So my guess is the word blah. Let's see what it does.
A little sarcasm. Oh, no sarcasm.
So it's an error. So it actually tried to, there's a very strange message, unrecognized function variable blah, but it's like it tried to evaluate what I typed in. Okay. Now, okay, this is strange. It's wanting to never guess. Okay. I honestly didn't expect this part of it for it to ask me again. Okay. Now, well, I'll type in another word. Oh, okay. Oh, because guess is an actual variable in my code. So it does have a value, but it's wrong. I'll try a different word. Oh, number is a variable in my code. The number is trying to guess. So when I typed in the word number, the input function got the value of number, which is the number I'm trying to guess. Which will, so then the value that's returned will match the number I'm trying to guess. And it says I guess right. So this input function behaving very strangely, but the point is, whatever I type here, it tries to evaluate it. So what I type here is a variable. It's going to fetch its value. Okay. Now, let's try a different input. That's erroneous. What if I type in a vector? I want to guess all the numbers at once. Apparently, the number it wanted me to guess was 1, and since it was in here, it interesting. Okay. I'll make my guess E, the exponential function evaluated at 1. Okay, obviously that's wrong. Okay. Wow, the last possible number was 1.
Right. 8.
Okay. So this code that I have, what?
Mine gets right at 10.
Oh, okay. Well, it's random, so it's going to be different. Okay. I have this code that's currently not being used because it's commented out. But if I were to use this in place of the while statement that's already there, so I'm gonna move it up here. I'm gonna comment this one out. And, okay, so this does some error checking for valid input. It's going to require that the number of elements in guess is only one. So in other words, what I did earlier, entering a vector, this would not allow that. NumL is short for number of elements. So its argument, if it's a vector or matrix, it'll tell you how many elements, total elements, are in that entity. So this condition is requiring that the I'm entering just one number. Also requiring that it actually is a number. So
Wait. What did you do in one of the lines?
oh, wait. This one? Or I can't tell what you're asking.
Number 5.
Oh, I put a % sign in front of it.
Why?
That comments it out because I don't want to be actually using it. Because I'm replacing this thing. I'm replacing this while statement with this one. So
That while statement with what?
with the one on line 6. This is also a while statement. It starts with while.
But it's not.
Okay. I copied it from down here. Yeah, so what I did was I selected that line and I cut it from there. Yeah, so go ahead and cut it, and then I pasted it up here. And once I pasted that while statement up here, I don't want to have the other one. That would be an error, so I put a % sign in front of it. So anytime, once there's a % sign on the line, that's MATLAB's comment character. Anything from that % sign to the end of the line is ignored. So that's to help you document, so you can use that to document your code. And commented out text is always in green in MATLAB's editor. So this while statement requires that I type in a single number for my guess. Any other kind of input, it'll just say my guess is wrong. Any questions about this modified code? So you can have compound conditions that are using and and or, for instance. Michelle's comment, cheat code. Okay. All right, I'm going to show other code has a while loop and one that's certainly mathematically more interesting. Newton's square root. Okay. What this code does, it uses a method we're going to be learning about toward the end of the semester, Newton's method, for finding a root of a function. So here's finding the root of a function x squared minus 2, which would be the square root of 2. So So essentially, this is an iteration that's going to converge to the square root of 2. Now, Newton's method, I'll talk more about that when we get to that to chapter 10. It's actually the very last topic of the semester. But I'm just including it here to demonstrate while loops. So first, I choose an initial guess. So I'll just choose x equal 1. So x is my approximation to the square root of 2. So initially, not a very good one. Then I print a message saying that we're about to compute the square root of 2. And then I have this while loop. Now, here I have while true. Now, that actually sets up intentionally an infinite loop because the loop runs as long as the condition is true. Well, true is always going to be true. But I do have a statement later inside the loop that will cause it to exit. So it's not really going to be an infinite loop. Like I said, always make sure that you have some way for the loop to end. This statement right here, x equals x over 2 plus 1 over x, that is what generates the new approximation of the square root of 2 from the previous one. And I save the other one, the previous approximation, in another variable called old x. And that's to so I can compare the new and old approximations. Then I display the new value of x that I just computed. And here is where I determine whether the loop should keep going. So I look at the absolute value of a difference between the new iterate and the previous one. And I make sure it's less than this threshold, which is a very small number, 10 to the minus 15 times the absolute value of x. So this is making sure that the what's called the relative difference, we'll talk about absolute relative error in the next chapter, needs to be less than 10 to the minus 15. So I want my iterate to be accurate to about 15 decimal places. So if this condition is true, then I want this loop to end, and that's where I use what's called a break statement. So a break statement will cause an immediate exit of whatever while statement or for statement, whatever loop is containing it. Here I use 10x raised to the minus 15 power, but you can also use scientific notation. I could have said 1e minus 15. So this will keep computing approximations to the square root of 2. Once two successive approximations are sufficiently close to one another, so within 10 to the minus 15 of each other, then I'll break from this loop. And so now the computation is finished. So then I display the value I got from square root of 2 right here. And then, as a way of verifying the accuracy of my approximation, I'll go ahead and square it and print that out, because that should be equal to 2, or very close to 2. So I'm going to go ahead and run this code, and then I'll take any questions about the code. So I'm going to return to a prompt, and I'll type in the name of the script, Newton's square root. Oh, whoops, sorry. I need to do format long first. So make sure you do format long before you run it. Because all these iterates most of these iterates look the same, they're not actually the same. You have to do format long and then run it. Okay. So my initial guess was 1. And then the next one is 3/2, and then this one is 17 over 12. And notice that it's pretty rapidly converging to a value. Notice the last two are exactly the same. The one before that is very close. It agrees to this many decimal places. So Newton's method, when it works well, it is a rapidly convergent iteration. So So it didn't take many iterates to converge to this many decimal places. So then this is my final value for square root of 2, at least 15 decimal places. And I go ahead and square it, and sure enough, it gives me essentially 2. So that tells me that it worked. All right, are there any questions about what this code is doing and how it's making use of a while loop, break statement, etc.? So a break statement only makes sense to use within a while loop or a for loop. Now, if you have like a for loop contained within a for loop, and then inside that is a break, it'll only break from the innermost loop. The outer enclosing loop will keep running. There's also what's called a continue statement. So what a continue statement does is that iteration of a loop will immediately terminate, and then it'll start the next iteration. So it's a way to skip over the current one. And I've used that sometimes, like if I generally want a loop to run, but there's certain cases where I don't want it to do anything, then I might use a continue statement. Okay. Let's for fun, I'm going to see what happens if I change the initial guess. I can change it to -1.
-1,
Yeah, instead of line 5.
not the only change.
That's the only change. Okay, so then I'll go ahead and run it again. And that just means it converges to the negative square root of 2. So in general, if for this kind of iteration,
Newton square root again.
yes. If the initial guess is positive, it'll convert to a positive square root. If it's negative, then to the negative square root. 0 should not be used as an initial guess because the this line right here that computes the new iterative from a previous one, it divides by x. So now the square root of 2 is plus or minus 1.414 to 135, etc. What if I chose a really bad initial guess? Like if I chose initial guess of, let's say, 100. So I'll just change that initial value of x on line 5 to 100. And let's see what happens. Yeah. And it still worked. If we look at the values, yeah, that's coming in from 100 very far away. It seems to be could be cut roughly in half. Because we have x over 2 plus 1 over x.
Isn't that stiff? It wasn't.
So yeah, ultimately it still converges, it just takes more iterations to do it. So in fact, any positive initial guess, it will converge to the square root of 2. Now, Newton's method is normally not so reliable, as we'll learn about when we get to that chapter. Most cases you need a decent initial guess to have convergence at all, but for a function this simple, it's just finding a root of x squared minus 2. It's not so picky. Now since it converged, here we have the final value of x that the iteration produced. So what I'm going to do is, if I look at the absolute value of x squared minus 2, because this value appears to be exactly 2. It's not exactly 2 though. So x squared minus 2 is a small number, in the order of 10 to the minus 16. So it is highly accurate. Actually, I think I recognize what this number is. 2 to the minus 51. That has to do with the fact that the double precision floating point number system that we're using here has it has 52 binary digits of precision. All right. Now, one command I've found showing you that is useful now and then is the help command. I can try to do help and the name of a command entry, for example, I'll do help is numeric, as I was using that earlier. So it'll print out in your command window
It is numeric.
a short documentation page. So it'll tell you how to use whatever you were looking up, and it'll give some examples. If you click on this link, documentation for whatever it is, then it'll take you to the full MATLAB documentation in another window. So you get even more information there. Now, suppose I do help and then Newton's square root. Now, help is usually for things that are part of MATLAB. Newton's square root is my own thing. But if I do help Newton's square root, it actually prints something out. And the reason why is this text right here, it's a comments at the top. So whatever code you write, if it's one of your end files, if you put some comments at the top, that's the help page, or that's what the help command will print out. I guess it keeps going until it encounters a blank line. So for instance, if this blank line wasn't here, I get rid of it and do help again, yeah, then it'll include that help page. So yeah, so that way you can,
Newton again. Help Newton's square root again.
oh yeah. Okay.
Wait, you did it 3 times.
Yeah, because the first time I removed the blank line, then I put it back. Just to make, I want to put the file back to the way it was. All right. Actually, when I write code, especially if it's something really substantial, I often write the documentation for it first. I write comments first before code. That way, it helps me keep my thoughts in order as to what I'm supposed to be doing. So I might start by writing in comments like a general description of what I want to do, and then I'll break that down into the parts, and then refine each part until it becomes very clear what I need to do from a coding standpoint. And I found it helps me write correct code sooner. Okay, so we've seen a number of M files. But all the M files that we've seen so far are script M files, like these two, where I'm just typing commands that I could just as easily type in the prompt. So basically, it's a way to save you typing in the command window. But there's also what are called function M files. So now I'm going to introduce to you MATLAB functions. Okay, so I'm going to start with a very simple function just to illustrate the concept of a function in MATLAB. So the file is convert temp. Okay, so all this function does, it takes as input a number or numeric data that's interpreted, assumed to be temperatures in degrees Fahrenheit. And then this function will convert them to degrees Celsius and return it as output. So the way you distinguish a function M file from a script end file is that in a function end file, first word, aside from comments, should be literally function. So this tells MATLAB that this is a function end file. Now, what follows is what's referred to as the signature of a function that indicates what is the name of a function, what are its input parameters or input arguments, and also what are its output arguments, which you might know as referred to as return values. So first you list any output values. In this case, we only have one, temperature in degrees Celsius. Then an equal sign. Output is optional. Like a function does not have to have either input or output arguments. Then after the equals is the name of a function, which should match the name of your file aside from a .m extension, because here in this code, you may know a function by this name, but MATLAB identifies it by the file name. So those should match to avoid causing confusion. After a function name, then if there are input arguments, they are in parentheses, and in this case, we only have one input and one output. So if you have multiple inputs and outputs, they would have to be in a comma-separated list. And we'll see an example of that a little later. So here I have some comments about what the function does. And then I just carry out the very simple computation. I take the Fahrenheit temperature, I subtract 32 to shift it, and then I multiply that by 5/9, just a formula for conversion from Fahrenheit to Celsius, and I assign that to the output, TC. So if you have an output, it must be assigned a value, or you're going to get an error. Because MATLAB is going to send this value back to whatever code is calling this function, and needs to know what to send. And that's it. That's all the function does. Ignore this for now. I'll talk about it later. So I'm going to go ahead and call this function from a prompt. They'll do convert temp to 12. That's the boiling point in Fahrenheit. So the result it should give me is the boiling point in Celsius, 100. Again, with -40, that is the only temperature that is the same in Fahrenheit and Celsius. So I get -40. Okay. Now, in this case, I have not assigned the output to any variable, so it's stored in this special variable and that I've introduced to you before. So I could do this instead. If I pass as input the freezing point in Fahrenheit, I'll call my function, and then the output will be stored in the variable freeze Celsius, and that would be 0. So now, so this is how you save the output of a function in a variable. Otherwise, it would get stored in the ands. Okay. Now, I want to point out different workspaces. Well, workspaces are portions of memory that MATLAB uses where it stores variables. So here it says here workspace. These are the variables that I've been using during this MATLAB session. Now, I'm going to make a variable. I'm going to call it temp, and I'm just going to assign a random number to it. Okay. Right. So now temp has this value 32345. Now, in my function, I have a variable called temp. It's assigned to the input temperature -32, and that value gets stored in temp. So what I'm going to do is I'm going to remove this semicolon. So when it makes the assignment to temp, it's going to print it out. Okay. So what happens is, I'll go ahead and call this function again. And it's going to,
3 Celsius convert to.
so what happens is, inside the function, 32 is the input. It comes in here, I take the input temperature 32, subtract 32 from it, and assign the result to temp, so temp in here is 0. But now the function is finished, and I want to print out temp again. It's still 32345, the value that I assigned it earlier. Reason why is this temp in my workspace and this temp here, the function, are independent. They have nothing to do with one another. They just happen to have the same name. So what happens is, when I pass input to a function, the values that I pass, like this 32 here, are copied into variables here. These variables are local to a function convert temp. They're created when the function is called. They go away when the function exits. The only data inside this function that goes back to the workspace is this output here, whatever output the function has. Everything else goes away. But the output in here is known as TC. But then that gets copied to whatever variable I have here that's meant to receive the return, the output argument value. So let's get something to keep in mind. When you have function M files, we have separate workspaces. This top level workspace here, and then a workspace within your function that is temporary, only active when the function is actually running. If you have a function that calls itself, in other words, recursion, each time a function is called, it has its own workspace. So each invocation has its own workspace. So that's something to keep in mind too, if you ever do anything like that. Whereas if this was a script M file, and I have a variable out in here that has the same name as the variable out here, those are the same. And a change I make in a script M file would take effect in the workspace. So that's the key difference between function M files and script M files. Function M files have their own workspace. Script M files do not. They share this workspace. Any questions so far about how functions work? Okay.
Put the semicolon back.
Yeah. Because I'm going to call this function again. I don't want to print it out every time. Now, every time I call this function so far, I just pass in a single number, but I don't have to do that. I'm going to create a matrix, a 2x2 random matrix, and I'm going to multiply it by 200. So these temperatures will be randomly chosen between 0 and 200. Okay, so those are my random temperatures. So I can pass this matrix to convert temp. And it will convert each entry of a matrix, it'll interpret it as a Fahrenheit temperature and then convert it to a corresponding Celsius temperature. So it doesn't matter whether I pass this function not a scalar or a vector or a matrix, but that's because the operations that are performed, subtracting a scalar or multiplying by a scalar, are done in the same way, whether it's a number, vector, or matrix, doesn't matter. I'll even try passing text. Let's see what it does.
Convert temp text.
Yeah, in single quotes.
Convert temp.
Now, it might seem like this would be a bogus operation, but it actually does something. The reason what it does is it takes each of these letters, each of these characters, the T, E, X, and T. It takes the numeric value of its ASCII code, and then it works with that. So basically, it took each ASCII code and converted it from Fahrenheit to Celsius. So not very meaningful, but. So to illustrate this, if I do convert temp with just the letter uppercase A, so that's the output. But I happen to know the ASCII code for uppercase A is 65. So sure enough, that's all. So that shows that this was what it's doing, is it's converting to ASCII code. Now what I could have done, I have this code down here. That is not being used right now, but it's, because it's commented out. I could check. I could require that the data that's passed in be numeric. Actually, I'm going to go ahead and put this in. So I'm going to move this code. I'm going to cut it from down below and paste it up here. And I'm going to uncomment it. So now this code is active.
Hang on. What did you just do?
That's why I was saying so earlier. Okay, hold on. I'll undo. Cut it from down here. And then I pasted it up here. And then I removed the percent signs in front of it. But it's no longer
You
ignored.
cut it, and then moved it to
Up.
line 2.
Yes.
First, move to line 2.
Okay. So what this code does, it first checks if the data is numeric. If it is not numeric, then it creates a text string. The \n right here is a new line character, and please provide numeric temperatures. And then it uses this function, error. What error does is it exits your code right away and prints out whatever string you pass it. So what I'm going to do is I'm going to call convert temp again with this argument text. And let's see what happens this time. So it tells me I have an error, and it prints out the error message that I provided. So that's a way to make your code print out an error message if some error condition arises. Okay. I have one more M file to show you. That's to do with a dot product that you learned about in calculus. I'm going to create a random vector, 3 elements, x, and then another random vector,
You dot.
also 3 elements, that'll be called y. So now I have 2 vectors, x and y, with the random elements. Now, I'm going to open this M file, rectangle 2.
Mine's not the same.
Yeah, because it's randomly generated. It's not going to be the same.
Edit that.
Rectangle 2.
Rectangle 2 dot down.
Yeah. The dot M is not required. It'll assume it. Okay. So what this code does, it takes as input two vectors, x and y, and then it returns two outputs. Both are the angle between them. The first output is in radians, the second output is in degrees. So this is how you specify a function having more than one output. You have to use square brackets around a comma-separated list of the output arguments. Now, before I do anything with these two vectors, I want to make sure that they're the same length. So I use this function, length of x. So this will return the number of elements in x. And then I compare that to the length of y. And if they're not equal, then I'm going to use this error function that I just used a little while ago to print out an error message and quit, saying that the vector lengths have to agree. Now, here's how you can compute a dot product for vectors x and y. If the vectors are column vectors, which in this case they are column vectors, 3 rows, 1 column, then x transpose y is the dot product. Here we have the transpose I showed you a couple classes ago. But this is not the safest way to compute a dot product, because this expression, x transpose y, is only valid if the vectors are column vectors, one of their row vectors. If any one x, y transpose, which would be an outer product otherwise. Whereas MATLAB has a function, dot, that I have commented out here. So I'm going to uncomment it and comment out the other one. So dot xy doesn't care.
You commented it.
Yeah, I put a percent sign in front of the old one, and I removed it from the new one. Dot xy will perform the intended operation regardless of whether x and y are row vectors or column vectors. So that's more robust. Okay. Once the dot product is computed, I also compute the norm of x and the norm of y. Norm, by default, computes what's called the vector 2 norm, which is the Euclidean length. So square root of a sum of squares of the absolute value of the vector's elements. And the reason why is the formula for the angle of a vector is you take the dot product of the two vectors divided by both of their norms, and that is the cosine of the angle between them. Then you use this function, a cos, which is like arc cos, or inverse cosine of the angle, and that will give you the angle between the two vectors in radians. Now, here I take that angle in radians and I convert it to degrees by multiplying by 180 over pi. But now, here I have a special variable called narg out. So that's predefined by MATLAB. Narg out is the number of output arguments the user actually specified. Because this function can return 2 outputs, that doesn't mean I have to specify 2 outputs when I call it. So what I do is down here I check, is the number of output arguments equal to 2? Because if it's not, then I don't want to bother computing the angle in degrees. There's no need to perform a conversion in that case. So I'll only do it if the user actually asks for it. So there's 2 variables like this. There's narg in and narg out. Narg in is the number of input parameters that were specified. This is useful for implementing optional arguments. So if you have a function and you want to have some arguments treated as optional, like you specify a default value if the user doesn't specify them, you can use narg in to check whether the user passed them in or not. And I've often found a need to use that. A lot of functions in MATLAB have multiple ways of calling them, multiple interfaces, depending on how many arguments were passed. And narg in and narg out are used to support having Those multiple interfaces. So if I go ahead and call this function, so right now I'm just gonna call rectangle 2xy with no outputs. So in the code, I have it print out and arg out, and it's 0 because I didn't put anything here. Or I could do and rad for angle and radians. So then when I run it again, it shows nRg out is 1, so I specified 1 output. It went ahead and computed the angle in radians, but it did not bother to compute it in degrees. And then if I want 2 outputs, both outputs, I'll go ahead and list those again in the comma separated list, enclosed in square brackets. So in this case, nRg out is 2, so it's a full number of outputs, so it computes the angle in radians, and then it goes ahead and computes it in degrees. Notice if I don't have a semicolon here, if I specify a number of outputs, MATLAB will print every single one of them in your command window, which you might not want to print large things. Now, if you try to pass too many outputs or inputs, MATLAB will complain immediately. So if I do something like this, x, y, y, MATLAB will just bail out right away, too many inputs. Similarly, if I have a third item here in the output argument list, again, oh, whoops. Got too many output arguments in that case. So you can never have too many. You can have too few, whether that creates a problem or not depends on what the code inside the function is doing. It actually comes to the end of my diary. There's still more things to show on Tuesday, graphics, polynomial functions, things like that. Yeah. Yes, that was for your benefit. I'm sorry, you have to wait. Okay, but since we have a little time, well, first, any questions about any of this, or if anyone has gotten started on the assignment, any questions about that? Okay, well, it's due in 12 days, so still plenty of time. That's quite a bunch.
Just late.
I don't know. Okay, well, I'm sure I'm boring you all anyway.
You gonna do diary off?
Well, sure. I don't know. I'm not gonna do anything else to spend that session, but yeah, might as well, since I need to upload that. Okay, so one more day of MATLAB tutorialing on Tuesdays, the long weekend, that I'm sure we're all very thankful for.
And asking, it'll start on homework.
Well, I mean, it'd be a good idea if we start on some of the homework anyway, but once the tutorial is finished on Tuesday, then you still have one more week to do the homework. But then in class, I'm going to move on into chapter 2. Okay. All right, I guess that's it. Okay, I'm going to stop recording.